Alright, so here we are in part 3, so we'll do the last 4 questions here as quickly as possible and get this all complete. So number 18 says evaluate the greatest integer for negative 79.6. Remember, these two sets of vertical parallel bars means the greatest integer, not absolute value, so don't get that confused. And remember, we needed to go left on the number line because the definition of the greatest integer was the greatest integer less than or equal to this number. So if we are on a number line here and we're at, so we would have negative 79 here and negative 80 here, and we're at negative 79.6, so approximately right here. We have to go less than or equal to, so the biggest integer less than or equal to this point. So we have to go left on the number line. We can't go right. So the answer is negative 80 here. That's the largest integer, the greatest integer less than or equal to this number. Okay, so the negatives are the more confusing part because your initial thought might be to say that negative 79 is it, but it's actually negative 80 because you must go left on the number line. Alright, 19 says sketch f of x equals the greatest integer of x. Okay, so if we draw this, remember, and we just scale this 1, 2, 3, 1, 2, 3, and negative 1, 2, 3, negative 1, 2, 3. Alright, so remember that the steps of this, remember this is the step function. So when x is everything from 0 to up to but not including 1, the y value, the output, is also 0. So each little piece is going to look like this, and once you get the pattern going, it's pretty fast. So then you step up, you go over, open dot, step up, filled in, over, open dot. So it looks like this over and over and over again. And then back this way, solid dot there, open, back, solid dot. Alright, so this is where it gets its name as the step function, and remember it's filled in on the left and open on the right, and then it's just you're stepping up each time you're increasing your y coordinate by 1, and that's really all that there is to it, because this is defined, remember, as the greatest integer less than or equal to x. So when x is exactly 2, your y coordinate would also be 2 up here, so you have to step up. When it's exactly 1, you have to step up here to 1. When it's 1.5, so when x is 1.5, your y value is 1. You have to drop down to the lowest, to the greatest integer that's less than or equal to. So you actually end up being at 1 here. When x is 1.9, you're still equal to 1 because you go down to the nearest integer. And when your x is, say, 2.7, you would be right here for your x coordinate, so that would be a y coordinate of 2. Okay, so that is, just remember the pattern, and it's pretty easy to graph. Alright, let's look at the last two, and this video will be done. Alright, so problem 20 says simultaneously sketch y equals x to the 5th and y equals x to the 7th. So these are power functions, and they have odd powers, so they are going to have that cubic graph shape. And so let's graph. It will be easier, I think, to graph x to the 7th first, the steeper one. So x to the 7th would be steeper, except between negative 1 and 1. So remember, it's a little flatter through this point, and then it takes back off like this. It never goes perfectly flat, by the way. It's still slightly increasing through here. Alright, so that's x to the 7th. Okay, so x to the 5th is going to increase at a less rapid rate, except in this zone from negative 1 to 1 where it's not quite as flat. So this thing would look more like more like this. Whoops, that's not right. It would look more like this. Like that. Okay, so right through here, this one's increasing, the green one, the x to the fifth is increasing at a more rapid rate, but once you get past the +1 coordinate here, this thing actually gets wider. So the x to the fifth is wider from 1 to infinity and -1 to -infinity, but it's going to increase at a more rapid rate in between -1 and 1. So those are the keys. X to the seventh overall is a more narrow graph. As you go out to positive infinity in the x direction and negative infinity in the x direction, but in that zone from -1 to 1, and we discussed that in that particular lesson why that is, the x to the seventh actually is flatter through that zone. Alright, so let's look at 21. Simultaneously sketch y equals x to the fourth and y equals x to the eighth. So we have even powers here, so we're going to have that parabola shape. So we'll draw x to the 8th first. So that's a very narrow or skinny parabola, but it's pretty flat down here at the bottom. It's never perfectly flat, okay, but just to try to draw this on this scale, we need to make this look a little flatter. And so let's see, that was x to the 8th. And then the x to the fourth graph is wider out here. So we'll kind of exaggerate this a little bit. So it's wider, except right through here where it's actually steeper, and then it ends up being wider. So that was our x to the fourth. Okay, so in this zone from -1 to 1, the x to the fourth graph is steeper, but from 1 to infinity and -1 to -infinity, the x to the 8th is the steepest graph. Alright? And again, we talked more in detail about that in the lesson on power functions. Okay, so that is it for the unit 8 review. See you in the next video.